All right, this video is going to go over 5.2a, which is starting off dealing with logarithmic functions, part 1, and evaluating logarithmic functions. So logarithmic is a fancy word. A lot of times we just abbreviate it and just call it logs. And that's what chapter 5 is all about, exponentials and logs. So just like adding and subtracting your opposite functions, they cancel each other out. Multiplying and dividing your opposite functions, they cancel each other out. Just like we talked about in the previous section, let me pull up my paper right here. We had something like this. We had something like 5 to the x power equals 625. We couldn't do anything to get that x down, so what we did was just we made them both 5 to the x power, or I'm sorry, 5 to the x and 5 to the fourth. Those 5s canceled out. But what if we had something like this, where if I have 256 equals 2 to the 8th, I can't make 256 2 to some power. So I can't make these the same base. Then what? So that's what logs do. So just like adding and subtracting are opposites, they cancel each other out. Multiplying and dividing, for example, are opposites, they cancel each other out. Logs and exponents are the same thing. Logs and exponents are opposites, they cancel each other out. So let's just kind of start off. It says, write the following exponential equation in its equivalent log form. So logs, by the way, are opposite, or they're the inverse of exponential equations, of exponentials. I don't know if that helps it, but all right, so 256 equals 2 to the 8th. So this is an exponential form. And we want to try to put it in log form. Now, it's just kind of like seeing where to put stuff. So kind of work with me for a second. We have 256 equals 2 to the 8th power. So I have my log. Just like 2 is my base here, 2 is going to be the base of my log. Notice exponents are like little numbers up top. This is the opposite. So this is a subscript. This is a little number on the bottom. So log base 2. Logs equal exponents. So our exponent here is going to be 8. So my log is going to equal 8. And we're going to take the log of 256. Boom, here's our answer. Log base 2 of 256 is 8. So let me write that how we would say it. Log base 2 of 256 is 8. So a lot of times people like to, I don't have enough colors here. I can't make enough colors. People like to color code to kind of see what's going on. So notice 2 is my base. So 2 is going to be my base. 8 is my exponent. So my log is going to equal 8. And we're left over with 256. Let me grab I think I have a green. Is this green? Yeah. All right, 256. So kind of see how things go. So let's recap this. So in exponential form, we have our base to our exponent, and it's going to equal our number. So this is an exponential form. This is the same thing as writing it in log form. So in log form, we have our log, we have that same number as our base. Our log is going to equal our exponent. And we're taking the log of our number. Oops. So these two are the same exact, they mean the same exact thing. They're just in different forms, just kind of like we did point slope form and slope intercept form. It was the same line, two different forms, same thing here. So this will be our exponential, and this will be our log form. So just kind of putting stuff in different places. All right, let's do another one. All right, so write the following exponential equation in its equivalent log form. 3 equals the fourth root of 81. So it's not really an exponential form yet. Let's put it in exponential form. So we have 3 equals 81. Remember that fourth root. And there's an 81 to the first power. That 1's up top, it's going to stay up top. That 4's on the bottom, it's going to go to the bottom of our fraction. So remember, 1/4 is the same thing as writing the fourth root. Now this is in exponential form. Let's put it in log form now. So we have our log. Our base of our exponent is 81. So the base of our log is going to be 81. I'm just trying to use colors to kind of help you. My log is going to equal my exponent. My exponent here is 1/4. So my log is going to equal 1/4. And we're going to take the log of the number that's left over, which is 3. So log base 81 of 3 equals 1/4. We're just saying 81 to the 1/4 power equals 3. So just putting things where they go. Let's do another one. Write the following exponential equation in its original, or in its equivalent log form. X equals 10 to the 7th power. This is our exponential form. Let's put this in our log form. So we have our log. Our base of this log, our base of this exponent is going to be 10. The base of our log is going to be 10. Our log is going to equal our exponent. This exponent is 7, so our log is going to equal 7. The x is left over, so we're going to take the log of x. So log base 10 of x equals 7. Notice again, 10 is a little subscript. Last one for this page. Oh, one more thing, but we're not talking about this one. Log base 10. Log base 10. We have two special cases. Log base 10, which is called common log. So I have common log of x equals 7. Give me one second. This is common log. So you know, like for example, you know how you have the square root and you don't need to write that little like 2 in the index because you know it's the square root. Kind of the same thing for log form. I don't need to write this base 10 because it's understood if there's no base, it's understood to be the common log. Common log means base 10. So common log means that we can just write it as log with no base, and it's understood that that's going to be log base 10. So that's our first special case. That's our first special case. Second special case, let's look at this next one. Write the following exponential equation in its equivalent log form. X equals e squared, so same thing. This is an exponential form. Let's put this in log form. We have log. Our base of our exponent is going to be e, so the base of our log is going to be e. Our log is going to equal our exponent. Our exponent in this case is 2. So our log equals 2. X is left over, so we're going to take the log of x. So log base e of x equals 2. Here's our other special case. This is what's called our natural log. So instead of saying log base e, it's understood we can say ln. ln. So instead of log base b, that's the same thing as saying ln. It's kind of like simplified. So ln of x equals 2. And that'll be our answer. So our other special case is natural log. So ln, which equals log base e. So if it's ln, it's understood to be log base e. If it's just log with no base, it's understood to be common log base 10. Anything other than 10 and e will have a base to it. So if you notice, we've seen log right here in our calculator. Notice above it is its inverse. Above it is 10 to the x power. This will kind of help remind you that log is base 10. Right here is ln. This is natural log. Right above it is e to the x power. That will remind you that ln is base e. So these are the two things that are in our calculator. Log, which is common log base 10, and ln, which is natural log, which is log base e. Those are our two special cases. Real quick too, everyone always says IN. It's not IN, it's LN. LN. All right, let's go to the next page. Okay, so write the following, going backwards, write the following log equation in its equivalent exponential form. So now we're going backwards. So now we're going to go from log form to exponential. So we have 3 equals log base 7 of 343. My base of this log is 7, so the base of my exponential is going to be 7. My log is going to equal my exponent. This log equals 3, so that means my exponent's going to be 3. And that number left over is 343. Boom, there's our answer. 7 cubed equals 343, which makes sense because 7 cubed is 343. Let's do the next one. Write the following log equation in its equivalent exponential form. Negative 3 equals log base 7 of 1 over 343. This is in our log form. We're going to write the same exact thing in exponential form. So my base, it's log base 7, so my base is going to be 7. My log is going to equal my exponent. This log equals negative 3. So my exponent is negative 3. So 7 to the negative 3 power equals that number that's left over, which is 1 over 343. So just seeing where stuff goes. 7 to the negative 3 power equals 1 over 343. Next two. Write the following log equation in its equivalent exponential form. ln of 10 equals y. Remember, ln is the same thing as saying log base e of 10. ln and log base e mean the same thing, equals y. So now we can go from log form to exponential form. So we have log base e, so my base is going to be e. My log is going to equal my exponent. This log equals y, so my exponent is going to be y. Equals a number that's left over, which is 10. So e to the y power equals 10. Nothing else to do. We're just putting it from log form to exponential form. Leave it just like that. Last one for this page. Write the following log equation in its equivalent exponential form. Log of 7 equals y. Notice there's no base, so it's understood to be common log. So this one up here was natural log. This one's understood to be common log. So if there's no base, it's understood to be log base 10 of 7 equals y. So we're going to go from log form to exponential form. My log is base 10, so my base is going to be 10. My log is going to equal my exponent. This log equals y, so my exponent is going to be y. And we're left over with the number 7. So we know our final answer is 10 to the y power equals 7. Alrighty, let's keep rolling. Next page. Find the exact value of the following log expression. Log base 6 equals 36. So kind of like what we did earlier, I want to write them as the same base. This is base 6, so I'm going to write 36 as 6 to some power. Well, I know 6 to some power is going to be, 36 is going to be 6 squared. So log base 6 of 36, which I can rewrite as 6 squared. So now here's the whole thing that logs do. Remember, logs are opposite of exponents. So what logs do is it brings the exponent from a little number up top down out front. So logs bring this exponent down out front. So log, bring the exponent down out front. That's what logs do. That's the purpose of our log. So that 2 is coming down out front. So 2 times log base 6 of 6. Let's talk about log base 6 of 6, a little note to the side. If we have log base 6 of 6, whenever they're the same, it's going to equal 1. Let me show you why. If we were to put this in exponential form, my base is 6, my log is going to equal my exponent, this log equals 1, so my exponent is 1, equals 6. This makes sense. 6 to the first power is 6. So whenever you see the same bases like this, it just goes to 1. So log base 6 of 6 is 1. So essentially that cancels out because 2 times 1 is just 2. We found the exact value. Done. Let's do another one. Find the exact value of the following log expression. Log base 8 of 1 over 4096. I want to write them with both base 8. So I know 8 squared is 64. I know. 8 to the third power will give us 512. 8 to the fourth power will give us that 4096. So in order to get that 1 over, I need to write it as a negative exponent. So we can rewrite this as log base 8. We can rewrite 1 over 4096 as 8 to the negative 4 power. Remember, the negative exponent's what's going to flip it to the bottom, make it 1 over. 8 to the fourth power is 4096. So log base 8 of 8 to the negative 4 power. What we said was logs bring the exponent down out front. So my exponent's going to come down out front. We're left over with negative 4 times log base 8 of 8. We just talked about log base 8 of 8 is going to give us 1. So essentially that cancels out because negative 4 times 1 is just negative 4. Final answer. Done. Let's do the next one. Find the exact value of the following log expression. Log base 5 of 1 over the 6th root of 5. So I want to rewrite this using both the same base of base 5, log base 5. I want to rewrite 1 over the 6th root of 5 as 5 to some power. I know that 1 over is going to give us a negative exponent, so flip it to the bottom. That 6th root, it's the 6th root of 5 to the first power. That 1's up top is going to stay up top. The 6 is the root. It's at the bottom of the root, so it's at the bottom of the fraction. So I can rewrite the 6th root as the 1/6 power. They mean the same thing, going back to intermediate algebra or algebra 2. So we did it. We rewrote it both with base 5. So now what logs do is bring this exponent down out front. So I have negative 1/6 times log base 5 of 5. We know log base 5 of 5 is just 1. So negative 1/6 times 1 is just negative 1/6. Another one down. Last one for this page. This ink is getting everywhere. Find the exact value of the following log expression. Log base 1/7 equals 1 over 343. So I want to write them both using the same base of 1/7. So log base 1/7 of 1/7 to some power. Now let's think. So I know 7 squared is 49. 7 cubed will give us 343. That means 1 over 7 cubed would give us 1 over 343. So we did it. Let me start over. We did it. We rewrote it both using base 1/7. All right, hard part's done. Now the exponent is going to come down out front. That's what logs do. So we're left with 3 times log base 1/7 of 1/7. We know log base 1/7 of 1/7 is just 1. So 3 times 1, just 3. Done. Let's go to the next page. All right. Find the exact value of the following log expression, log base 1/4 of 64. Log base 1/4 of 64. I know I can't change that base, so I know it's going to be log base 1/4. I'm going to rewrite 64 as 1/4 to some power. Now let's deal with the 4s. We know 4 squared is 16. 4 cubed is 64. All right, so we know it's going to give us, and now this one's flipped. So I need the negative exponent. So 1/4 to the -3 power, the negative's going to flip it back to a whole number. And then 4 cubed would give us 64. We can put that in our calculator if that helps you to kind of check your answer. 1/4 to the -3 power, boom, 64. Perfect. All right, so now this exponent is going to come down out front. So -3 times log of 1/4, log base 1/4 of 1/4, log base 1/4 of 1/4 is just 1, so it cancels out. So -3 times 1 is -3. Done. Couple more examples. I know there's a lot of examples. This packet's long. Reason being is these problems don't take very long, but every single problem is kind of different. So I wanted to give us enough examples that you feel confident and comfortable going to the homework. Remember, these are straight from your homework. So you should see some that are super similar on your homework. Use your notes next to you as you're doing your homework, and then slowly wean yourself off. Next example, find the exact value of the following log expression. Log base 5/4 of 256 over 625. All right, so I know I want it to be log base 5/4 of 5/4 to some power. Let's just see what power. So we know we have 5. So 5 squared is 25. 5 cubed is 125. 5 to the 4th power is 625. Okay, let me write that as a little note over here. So we know 5 to the 4th is 625. Okay, well then what about 4 to the 4th? 4 to the 4th will give us that 256. Okay, so we know the 4th power will give us these numbers, but these numbers are flipped. That 5 to the 4th power is on the bottom now as 625. The 4 to the 4th power is on the top as 256. So it needs to be to the 4th power, but it also needs to be flipped. So that's going to make it a negative exponent. So 5/4 to the -4th power. So the 4th power would give us 5 to the 4th would give us 625 over 256. To flip it would give us that negative exponent. All right, so now we wrote them both using the same base of 5/4. Now our exponent's going to come down out front. So we have -4 times log base 5/4 of 5/4. Log base 5/4 of 5/4 is going to give us 1. So it's going to cancel out. -4 times 1 will just give us -4. Done. Next one, find the exact value of the following log expression. 729 equals 9. Okay, so let's see. How does 729 and 9 deal? So wait, let's just, 9 squared is 81. Oops. 9 cubed will give us 729. Okay, so side note. So 9 cubed would give us 729. Okay, so remember, I want to rewrite it as 729 to some power. So I want to rewrite 9 as 729 to some power. So if we take the cubed root of both sides, that way the cubed root and the cubed cancel out, we're left with 9 equals the cubed root of 729. And then the cubed root, we need to write an exponential form. We know the cubed root is 729 to the 1/3 power. 1's up top, it's going to stay up top. That 3's on the bottom, it's going to go to the bottom. So I can rewrite 9. So instead of 9, I could rewrite it as 729 to that 1/3 power. 729 to the 1/3 power. Okay, we did it. Now they're both base 729. So that 1/3 power is going to come down out front. We're left with -3 times log base 729 of 729. Log base 729 of 729 is going to be 1, so it cancels out. We're left with 1/3 times 1, which is 1/3. Again, maybe you would have never thought about that. That's why we're going over it together. The more you practice it, the better it will become. Last one for this page. Find the exact value of the following log expression. Log base 2 of 2. Just like log base 729 of 729 was just 1, log base 2 of 2 is just going to be 1. That's it. So if you want to think about it, this 1's up front, it's going to come down. That's how we get 1. So if we have log of some number, log base some number of some number, it's always going to give us 1 every time. So remember, 2 to the first power will give us 2. Just like we talked about over here. Log base 6 of 6 is 1 because 6 to the first power is 6. So that's kind of like our rule. All right, so last page, 5.2a. Oops. So find the exact value of the following log expression, log base 9 of 1. So whenever we have log base anything of 1, it's always going to give us 0. So another rule. Log base any number of 1 is always going to give us 0. Reason being, let's put this in exponential form. Our base is 9. Our log is going to equal our exponent. Our exponent's 0. Well, anything to the 0 power is always 1. So log base anything of 1 will always be 0. All right, so find the exact value of the following log expression. I'm going to check one thing real quick. Okay, yeah. All right, so find the exact value of the following log expression. Log of 0.00000000001. All right, so notice there's no base. So it's going to be common log. So it's the same thing as saying log base 10. So I want to write this as 10 to some power. So this is kind of like putting it in kind of like scientific notation. Move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Move it 10 times. It's a really small number, so a negative exponent. 10 to the negative 10 power would give us 1e to the negative 10, which is the same thing as saying 1 times 10 to the negative 10. Take the decimal, move it 10 times to the left, which is what we did here, and you get back to this number. So we have base 10, our exponent's going to come down out front. So negative 10 times log base 10 of 10. We know log base 10 of 10 is going to be 1. So negative 10 times 1 will just give us our final answer of negative 10. Last one for this section and this page. Find the exact value of the following log expression, ln of 1 over e to the 6th. We know this is ln, so we know this is going to be natural log. So I can rewrite this if you want as log base e. Because that's base e, I want to rewrite 1 over e to the 6th as base e. The 1 over means it's going to be a negative exponent, and it's to the 6th power. So e to the negative 6th power will make it 1 over e to the 6th. Now I wrote it with the same base, so our exponent's going to come down out front. So negative 6 times log base e of e. Log base e of e is just 1. So it cancels out. Negative 6 times 1 is just negative 6. Done. And that is everything for 5.2a. Thank you for watching. Please let me know if you have any questions.